Hey everyone. Today I'm going to tell you about the scientific theories that explain the birth of our planet and the solar system. You will also find in the description of this video various links to other related topics I recorded, such as the Big Bang or the journey to the sun. But for today, make yourself comfortable because this is going to be a long trip to space and time, and this is starting right now. 4.5 billion years ago, the sun and the planets revolving around it did not exist yet, and our solar system says the main theory explaining its formation was just a large cloud of gas, or a nebula as this is called, floating in space. The matter of this nebula was already extremely ancient. Like all matter in our universe, it would have appeared 8 or 9 billion years before, with the Big Bang, when from an infinitely hot and dense point, our universe appeared and started to expand. As its temperature was decreasing, matter appeared, especially simple atoms of hydrogen and helium, and this matter floated in space under this form of nebulas maintained together by the gravitation. The most widely admitted theory says that solar systems, stars and the planets around appear when these nebulas start to aggregate, and this may happen if a nearby star dies, and when it disappears, it sends a shock wave in space which can hit a nebula and transmit it kinetic energy, like the wings of a windmill that starts to rotate on itself, and the rotation of the nebula with the force of gravitation concentrates most of the matter towards the center of the nebula and flattens it. The concentration of matter, mainly hydrogen, in the center gives birth to a star where the atoms of hydrogen merge together, liberating a massive energy. And at the periphery of this star, in this large disk around it, other smaller objects can appear as the atoms collide, becoming stones, and continue to aggregate, becoming asteroids. And as the collisions continue, protoplanets appear, representing just a tiny quantity of matter in comparison with the star at the center of the system, but big enough to aggregate the matter in their periphery. For example, in the solar system, the Sun alone represents more than 99% of the matter in our entire system, and the planets, including the Earth, Jupiter, Saturn, and all the others, together less than 1% of the mass of the solar system. And this is how the Earth would have appeared 4.5 billion years ago, as one of the planets forming around this new star that we call the Sun. The planets forming nearer to the central star would be more likely to be terrestrial, rocky planets like Mars, Venus, or the Earth, whereas planets appearing farther from the Sun, from the star, could be giant gas planets like Jupiter or Saturn. But scientists discovered in the past few years, by studying exoplanets, that sometimes gas giants could be much closer to their Sun, what they called hot Jupiters. And this is challenging the traditional models explaining how the planets appear in a given solar system. However, 4.5 million years ago, when all this happened and the Earth formed more or less at the same time as the Sun, it was extremely different as a planet from what we know today. First, because the Moon, its satellite, was not already there, and the main theory explaining the formation of the Moon is that two planets appeared on a similar orbit around the Sun. There was also a smaller planet, maybe one the size of Mars, and at some point the two planets, the Earth and this planet called Theia, collided, merging collision was violent enough to make a part of the crust of the Earth escape from the planet and aggregate in space to create the Moon. So the Moon would have been formed by debris coming from the Earth that would have taken a round shape in space due to the gravity. And the face of the Earth in this time was very different to what we know today. The planet was constantly hit by asteroids who merged with it and increased its mass. The planet was constantly in fusion, like a giant ball of magma, of lava. Its atmosphere was made of light gases such as hydrogen and helium, nothing to see with the current atmosphere. And these constant collisions with asteroids constantly increased its mass, and as the planet was in fusion, the heaviest components, the heaviest elements that composed it tended to migrate towards the center, the core of the planet, and especially iron, which would be extremely important later on, because this core of the Earth, composed of a lot of metals and iron in particular, generates a large magnetic field around the Earth, which would be necessary for life as we know it to appear later, because this magnetic field protects the surface of the Earth from radiations in space coming essentially from the Sun. This young Earth was now born, and its history could start to describe, to explain the history of the Earth. Scientists have divided it into various periods, and within each period there are sub-periods, different ages, but the longest ages or eras used to describe the history of the Earth are called eons. And the first of these eons, called the Aegean, named after the Greek god of hell, Hades, would cover the first 700 million years of the Earth, about 1/6 of its total history. It's called the Aegean because the Earth at this period was probably close to our images of hell with an incredibly active volcanic activity, an extremely high temperature, no atmosphere as we know it today, and no form of life as we know life nowadays could have appeared or even less survived in such an environment. However, bit by bit, the appearance and temperature of the Earth started to change. The temperature decreased, the Earth cooled down, and as its first atmosphere, made of hydrogen and helium, had been destroyed, had vanished in space due to the temperature of the Earth and the solar wind that was hitting it, another atmosphere made of gas coming from the lava, especially with carbon dioxide and water under a gas form, appeared, and as the temperature was decreasing, it started to rain on the Earth, and the liquid water gave birth to the first oceans on our planet. The appearance of the Earth would change again a lot in the following eras, and none of the continents as we know them today was visible yet, but the Earth was starting to look more like we know it, and adapted probably this blue color given by liquid water at this moment by the end of the Aegean age. As the Aegean was coming to an end, the first forms of life would appear in these new oceans about 3.5 to 3.8 billion years ago, the most basic forms of life. But this is another story that I could tell you another time, if you wish. Before I leave you, I would like you to realize how ancient the planet where we live is, and how recent as a species we are. When we talk about the history of the Earth, we talk in billions of years, and when we talk about the appearance of elaborate forms of life, we talk in millions or hundreds of millions of years. But the appearance of man is something that we measure in tens of thousands of years only, and the appearance of civilization is something we measure in centuries or millennia at most. So So that if the history of the Earth was an entire year, at this scale, life would have appeared in April, more or less, and men would have appeared on the 31st of December, in the last seconds before midnight and the end of this year. So you realize how tiny, how insignificant and almost absurd our history is in comparison with the history of our planet and even more of the universe. As usual, I hope you found it relaxing and interesting, and I hope to see you soon for another topic. Bye bye.